So I'm back with the last video for chapter 9. These are the extra problems, and I realize that there's a lot here. That's why I'm giving you Friday to work on them, next Tuesday to check your answers so that you have plenty of time to get these done. So next week is just checking these answers and working on a test. So you've been working really hard. I know it's been a lot of work, and so I'm letting you take a little easy next week. And the week after that is a fun little lab that if you have siblings at home, you can all even work on that with younger siblings and make it a family activity so that the whole family's having fun with that. Well, I have 4 pencils loaded up here and lots of paper, and so here are the answers to the homework, so you can check your answers and then only skip to the parts of the video that you need. So here are the answers for question 1. Questions 2 and most of 3, I'll flip the page for the rest. There's the rest of question 3. I'll move it over. Oh, I'm not getting everything for question 4. There's all of it for question 4. Questions 5 and 6 and part of 7. The rest of 7 and question 8. Most of question 9. The rest of question 9. Question 10. The last one for question 10 there. And question 8. Now that you've had a chance to check your answers, I'm going to work through all of those problems to show you exactly how they're done to hopefully answer any questions you have about those. So let's go. So the first question, 1A, asks how many moles of N2O4 are in 26.75 grams of N2O4. So we're starting with 26.75 grams of N2O4. And we need to get to moles. So we're in mass. Now remember, to get to moles, we have to find the molar mass. So I'll find that down here. So N2O4, I have 2 nitrogens. So from my periodic table, remember I'm getting all of these masses from the periodic table. We just look at the mass here. So it's 14.01 grams. Plus I have 4 oxygens, so it's 4. From my periodic table, I have 16.00 grams. Remember, we are rounding all of these off to 4 significant digits. All of these numbers have 4 significant digits because some of those numbers are really long and we don't want to have to be writing all of that. And when I do the multiplication and the addition, I get 92.02 grams of N2O4 in 1 mole. So I can go back over here. I put my 92.02 grams of N2O4 on the bottom so that it cancels out, and I know that that is 1 mole of N2O4. When I divide 26.75 by 92.02, I get 0.2907 moles of N2O4. Now, remember, I start out with 4 significant digits, I end with 4 significant digits. Okay, moving on to B. I'm asked how many moles of Na2SO4, sodium sulfate, decahydrate are in 8.99 times 10 to the 24th formula units of that compound, of that hydrate. So I start out with my 8.99 times 10 to the 24th units of Na2SO4 10H2O. I realize that's a lot to write, but it's a good idea to write it out because you know that as we get into our stoichiometry problems, when we involve the formulas, it's important to have those labels. If we get in the habit of dropping things now, we'll drop them later and we'll get into trouble. Now remember, Avogadro's number, 6.022 times 10 to the 23rd units of Na2SO4 10H2O is 1 mole of Na2SO4 10H2O. Those cancel. I'm in moles, which is what I want to be in. And when you do the division, you get 1.49 moles of sodium sulfate decahydrate. So just a lot of numbers there. And remember, we have 3 significant digits here, so we have to end with 3 significant digits. Okay. Oh, and remember, Avogadro's number. Important number to know. Okay, moving on to C. We have aspirin, and they want to know the moles of aspirin in 1 aspirin tablet. And they give us the formula for that. That's C9H8O4. So we start out with our mass, which is 0.324 grams of aspirin. And we're going from grams to moles, so we have to know that molar mass. And they gave us the formula, so we have C9H8O4, so we can find the molar mass. 9 carbons, so 9 times 12.01 grams from our periodic table, plus 8 times 1.008 grams, plus 4 times 16.0 grams. When we do our multiplication and add those all up, we get a total of 180.15 grams of aspirin in 1 mole of aspirin. So I come back up here, I put that on the bottom so I can cancel that out. Remember, when we're canceling, we have to have the same thing on the top and the bottom, and that is 1 mole of aspirin. When I do the division, 0.324 divided by 180.15 grams, I get 0.00180 moles of aspirin. Okay, so that is question 1. Going on to question 2. I'm asked to calculate the molar mass of the following compounds. The first one, A, is lead chloride, lead 2 chloride. So for this one, from my periodic table, lead has a molar mass of 207.2 grams. Chlorine, I have 2 of those, and it's 2 times 35.45 grams from my periodic table. So when I go ahead and I do the multiplication and the addition, I get 278.1 grams per mole. I could put the per mole there if I want to. If you don't put that, that's fine. I'm not going to take off for something like that. Okay, for B, I have H2TE. So I have 2 hydrogens, 2 times 1.08 grams from my periodic table, plus tellurium, which is 127.60 grams from my periodic table. Do the arithmetic there, and I get 129.6 grams per mole. Okay, moving on to number 3, 3A. We're revisiting that dinitrogen tetroxide. So how many N2O4 molecules are in 8.6 grams of N2O4? I start with what I know, 8.16 grams of N2O4. I realize that if I want to go to molecules, I have to go through moles first. And so I need to find the molar mass of that. The molar mass of N2O4 is, oh, we found it up above already, so I'm not going to redo that. We found it in question 1. So I'm just going to reuse that. Don't need to do that calculation over again. Why waste my time? If you've already done it, just use it over. Okay, so I have that. That is 1 mole of N2O4. I know I set it up right because these cancel. And I know that 1 mole of N2O4 contains 6.022 times 10 to the 23rd molecules of N2O4. So I do my multiplication across the top, divide that by what's on the bottom, and when I do that I get 5.34 times 10 to the 22 molecules of N2O4. Okay, I'm going to use another sheet here for B. So this is 3B. And this time we're back to our sodium sulfate decahydrate. So I'm given 3.87 moles of that compound. And I want to know formula units. So I know that in 1 mole of this compound, I have Avogadro's number, 6.022 times 10 to the 23rd units of that compound. And when I do my multiplication across the top, because I'm just dividing by 1, I get 2.33 times 10 to the 24th. Formula units. Na2SO4, 10H2O. Remember the difference between YA is called a molecule is because that is covalent. These are two nonmetals. We have to call this compound by formula units because it is ionic. That's the difference there, why we're using the different terminology. Okay, going on to C. No, I'm videoing. They wanted to know hydrogen peroxide molecules are in 1 liter of 3% hydrogen peroxide purchased at the drugstore. So they want to know how many molecules are in 1 liter of a bottle of hydrogen peroxide. So this, actually, if you didn't get this on your homework, this was the toughest problem you're going to see. So don't worry about it too much, but I'm going to walk you through this anyway. So we start out with the fact that we have 1 liter, okay? 1 liter of hydrogen peroxide. Of 3%. And they told you, don't forget about the density, that the density is 1 gram per milliliter, the same as water, because it's mostly water. So we have to convert from liters to milliliters to use that. So 1.00 liters is 1,000 milliliters. So our liters cancel out. Then we're going to use that density. We know that in 1 milliliter, there is 1 gram of this substance. Now this is where the 3% comes in. The 3% means that in 100 grams of solution, there are 3 grams of hydrogen peroxide. Now these are all canceling out as we go along. I'm going to run out of room. Now, our hydrogen peroxide, actually let's move this down. So I'm going to continue the problem down here. And we need now our molar mass of hydrogen peroxide. So 2 times the hydrogen, so 2 times 1.008 grams from my periodic table, plus 2 times the oxygen, which is 16 grams. When I do the arithmetic, I get 34.02 grams of hydrogen peroxide in 1 mole. So I go back up here. Remember, I had to split this problem. So I'm just extending that. So I go back down here and my 34.02 grams of hydrogen peroxide goes on the bottom so that that will cancel. My 1 mole goes on the top, but I'm getting to particles. So I have to put 1 mole of hydrogen peroxide on the bottom and Avogadro's number on the top. 6.022 times 10 to the 23rd molecules of hydrogen peroxide. And I ran out of room again. When I do all of that multiplication across the top and then divide by what's on the bottom, I get 5.31 times 10 to the 23rd molecules of hydrogen peroxide. You will not have as hard of a problem on your test. So if you had difficulties with this one, don't worry. You're not going to have to worry about that. I'm going to pause my video right here and I'm going to make another video for the next problem so that this doesn't get too long. So I'll be back in a few minutes.